So often asked the question that basically boils down to, but does order matter? Yes, order matters. So here's my stupid real-world example of why order matters. Okay? This is your car. Yay, car. Right?
That's attractive.
That's a Tetris piece.
Whatever. Use your imagination, all right?
I use my imagination on the other one.
Here is a garage into which you would like to put the car,
It's a house.
right? No, it's a garage because the door is really big. I don't know, man. So, what is your procedure for putting the car in the garage?
Is there already running?
X minus.
Yeah, okay, so you've pulled up in a running car to your garage, right? And so your list should be something like this. Push button,
Oh, yeah.
right?
That would be fun.
I open the door,
That'd be good.
right?
Pull
Drive in,
in. Keep driving in.
and then what?
Park.
Push button the car.
Park it.
Park, turn off the car, right? Car off,
Push it out.
push button, right?
And then get out.
Right, and then go about your life. You may assume the garage is attached to the house. Otherwise, you have to go out of the garage before you push the button. Done. You guys see this? So, this is my function composition, right? So my functions that are happening are push the button, drive in, car off, push button. What happens if I do those in a different order? Like what happens if I push the button, then drive in?
That's expensive.
Yeah, it's really expensive because the door is freaking closed.
No,
You guys see that?
Go ahead fast enough.
How do I back out of this?
What's that?
If the car's already in the garage, how do you get back out?
Push the reverse.
Yeah, you do the opposite steps in the reverse order, right? You're manually making an inverse function. So the graph shifting analogy, like why this matters for graph shifting, and it doesn't always. Like some of the steps, it doesn't matter which order you do them in.
Multiplication stuff.
Like for instance, if I had turn the car on and push the button, right? It wouldn't matter whether I turned the car on and then opened the garage or whether I opened the garage and then turned the car on, right? Like those result in the same state. The car's on and the door's open. You guys see that? So that's things like, it doesn't matter if you shift up and then do a horizontal flip, as long as the function's symmetrical. You guys see that? In fact, even if you do, right, shift up, horizontal flip, or horizontal flip and then shift up, right? Those two things aren't going to matter. Like, those aren't going to affect each other, which order you do them in. You guys all see that? Some of them do matter. Like this one, fine. No worries. Order doesn't matter there. Can you guys give me an example of when order would matter?
Compressing 3x plus 2.
Okay, 3x plus 2.
You have to multiply first. If you add 2 and then times it by 3, it's a different number.
Good. You guys see that? Like, if I'm doing multiply by 3 and add 2, right? So I'm thinking, here I've got a vertical stretch, right? And here I've got a vertical shift. I'm just assuming these are happening after the rule.
Okay.
So like, I'm thinking about the function 3 half of x plus 2. Right? So that's a vertical stretch by 3, then move up. Would it matter if I did that the other way? If I move up by 2 and then stretch by 3, what's
You
different?
would have to change to plus 6, right? Because
Good, you're stretching the shift up you already did.
Yeah.
You guys see that? So some of them, yeah, the order doesn't matter. Others you got to be really careful. So vertical stretches and vertical shifts, you need to be careful which order they go in. Vertical stretches and vertical flips. Does it matter? No. If I do a vertical stretch or a vertical flip and a vertical shift, then I gotta be careful, right? Because the order is gonna matter. You guys cool with that? And really, you can see that algebraically, right? If I do these in the other order, if I do plus 2 multiplied by 3, right? Algebraically, that's going to get me to f of x plus 2, right?
All that times three.
And all of that times 3. So you can see that algebraically, right? I'm stretching the shift. That's just the distributive property again. You guys cool?